Hello, my name's Amanda Fleck, and I'm going to talk to you today about literacy and language in science education. So first of all, we talk about literacy a lot in science. We don't necessarily talk about language. And for me, I think language is quite important because it's the medium of how we communicate. So I think it's a bit of a mistake to call it just literacy in science. So language is language development involves the development of skills used to communicate with others through languages, including things like sign languages. It's how we communicate with each other. And there's a lovely little link to a course there on Seneca Learn, whereas literacy is how students or people learn to read and write. And I think that distinction is really important, especially when we're talking about things like vocabulary. It isn't just literacy, it's the language. And this is one of my favourite quotes. Biology is not plants and animals, it's a language about plants and animals. Astronomy is not planets and stars, it's a way of talking about the planets and stars. So it's not enough to just say we know biology. We've got to know the language of biology. We've got to know the language of physics, the language of chemistry, or we can't communicate that. And what I'm going to do today is I'm going to talk primarily about this report. This is something I was lucky enough to be involved with. There is a link at the bottom there to this report. It actually followed on from the secondary science report, but improving literacy in secondary schools. And it talks about the need for how this needs to be sort of bespoke for different subjects. So I'm going to look at the first three recommendations. I just don't have the time to do the rest of them. So the first one is prioritise disciplinary literacy across the curriculum. Now, disciplinary literacy, what it means is looking at literacy and language through the lens of the individual subjects, rather than, I mean, we have some amazing literacy coordinators in schools all over the country. You just need to go onto Twitter to see some of the wonderful things that they're doing. However, if it's just a catch-all of literacy, then it's not necessarily going to suit all subjects. For example, comparing things like science to drama or English, the literacy and language needs can be very different. So disciplinary literacy is looking at it through the individual subjects. And I think this is something that science teachers have been looking for a very long time. Not the same strategies, not everybody has to do, I don't know, a PEE or a PEEL paragraph, or everybody has to on the third week of the term on a Tuesday afternoon make sure that they're doing paragraphs in science, or a literacy activity must be on every week of the scheme of work. I think it's about saying, where does literacy naturally fit within the subject? And I think that's really, really important. Don't force it, make it work, because we cannot do science unless we actually have the language. So recommendation 2, provide targeted vocabulary instruction. This is my favourite thing. I love words. I think that without knowing the vocabulary, we can't speak. It's like learning a foreign language. The first thing you do is you start looking at the vocabulary. You need the vocabulary to learn the science. So why does the language, why do the words matter? There's a 30 million word gap between children from the wealthiest and poorest families. The word gap is evident in children from 18 months. So that means that children at 18 months are at a disadvantage because they know less words, which means they haven't got the tool, they know fewer words, which means they haven't got the tools to communicate as well as other children. And then the OUP did a report, and secondary school teachers, and they found, and the report found that between year 7 and 11, that the students who came in with low literacy left with low literacy. And this is the Matthew effect. You start off poor, you stay poor. You start off rich, you stay rich. So we've all seen the graphs where if you've got a good vocabulary, it's a much steeper gradient. If you've not got a good vocabulary, you're still disadvantaged. And that goes all the way through school. And I think it's about how can we address that. Now, for each of these, there is a link on there to those reports. So, socioeconomic status and the word gap. We know this is from a review of socioeconomic status and science learning by the EEF. Children from lower income families and those with English as an additional language have a larger word gap. And the studies say the most consistent predictor of students' attainment in science is how literate they are, how well they can read and write about science. Remember, the language is the words, but the reading and writing is the literacy. So that might be a bit of a shock, because I've heard some people say, well, this student is wonderful at science, they're amazing, but actually they've got really poor literacy. They can't access the curriculum if they've got poor literacy. If you can't read and write about science, it's incredibly difficult to access. So this brings us on to looking at words. How many keywords are there? This is the issue. There are a multitude. I think I'll talk later on, I think 68 in the photosynthesis topic for us in year 9, and that's just science-specific words. We encounter new language in science through every other day, and we're expecting students to get used to this novel language. We are fluent in the language of science. If we liken it, I often liken it to learning a foreign language. And anecdotally, I think this in this book as well, we've got Wellington and Osborne's book here, they talk about it being science is like teaching a foreign language. And if you look at the sort of language curriculum, look at the speaking to MFL teachers, we actually have a very similar number of novel words to learn as they do in MFL, which might be shocking to some of you, but it's not surprising. So I do think it is very much like learning a language. So 68 keywords on the photosynthesis topic alone. And some of these aren't easy. We've got things like, your transpiration, translocation, xylem, phloem, palisade, other things in there, like knowing the difference, respiration, concentration gradient. These are some of the challenging words. Even looking at the heading here, factors that affect photosynthesis. You've got words like factors. What happens if a student doesn't know what a factor is? They can't even access this. So a lot of new vocabulary. And as well as teaching the concept of translocation and the process of translocation and transpiration, you've also got to embed this language. So it's really a challenge for us. If we don't embed the language, the students won't be able to make meaning of the work that they're doing. So tiers of vocabulary. This is from Beck, McCowan and Kukan, and these are from this book. It's a fabulous book for anybody who's interested in vocabulary, bringing words to life. So you've got your tier 1 words. They are the words that come that students come to school with. Basic words, clock, happy, baby, those sorts of things. Tier 2, these can often be problematic. They're frequently used in text, so students aren't always exposed to them through spoken language, but they can be more often in text. And this can go across many domains in school. And the issue with these is they can be quite culturally specific. They can be, whether you're a child in a city school or whether you're a child in a coastal school, that tier 2 language can actually make a difference in what you're exposed to. And if you don't read widely, you will probably have a deficit in your tier 2. Command words can often be tier 2. And as I said there earlier, factors would be a tier 2 word. Tier 3, I think science teachers more or less have got this nailed. I think we're pretty good at this. It's uncommon words associated with our actual domain in science. So we've got isotope, photosynthesis, transpiration, translocation. And I think we do that pretty well, science teachers. When I was first teaching, I had displays across my room with all of the keywords. But what I soon found out is when I'd go into some subjects, they'd have the words displayed and they had them up all year. I had to change mine every time I did a topic because there were so many keywords. So I'd have these huge boards. They were like corrugated plastic boards, where we'd have them in the staff room, in our science staff room, and we'd change them every topic because there were so many words we couldn't fit them around our rooms. So that's your tiers of vocabulary. So sometimes there's confusion, and this is one I commonly use. You can see here I'm Googling something, and what I'm Googling is tissue. I was looking for images and we can see here there's a few images of animal tissues. I was looking for images of animal tissues. And I just thought, wow, that's actually amazing, because that's a tier 2 word tissue. Everybody should know tissue, or even tier 1. But actually, in science, it's tier 3, means something specific. Another one, this is irritation to most teachers, and this is weight, whereas what we can see on there is mass. And that is that an everyday language. We don't say, can you measure me a mass of? We say, can you weigh me this? Can you weigh out the flour? Even though that's not technically correct. So I think we're pretty good at this in science, that we look at the difference with those, but we need to be reminding students all of the time. So this is some work that was done by Pixel a couple of years ago, and it's the frequency of tier 2 and tier 3 words in a chemistry paper. So examples of the tier 2 words here is one that's a bit of a bugbear. Suggest is one that's a bit of a bugbear for science teachers, in the fact that it's apply your knowledge to a novel situation. And suggest isn't, oh, I've had an idea, what do you think? And so it has a specific meaning. Another one here, describe and explain, huge issues. Every single examiner's report for years and years said students do not know the difference between describe and explain. And if you don't know the difference, you can't answer that question. A good tactic to use with this is use an everyday occurrence like brushing your teeth. Describe how you brush your teeth. Explain why you brush your teeth. And then you can have a go at doing some questions on describe and explain. Other things here, batch. You're asked about, I don't know, batch culturing of microorganisms, or to make insulin, or that sort of thing. If you don't know what batch is and what yield is, you won't be able to answer that question. You can't access it. So these are the tier 2 words that maybe you need to make sure you look through your exam papers and highlight them, and just do some training with your team. Tier 3 words. So here, nice and easy, most of these. These are fine. We can deal with most of these. But it's this tier 2 one. If you miss one of these words, you can't do that question. So what do we know about the structure of words? And the structure of words is called morphology. It's looking at different parts of a word. And this is one of my favourite things to do, and my students really enjoy this. Looking at the prefix, which appears at the beginning of the word. And I have a lovely sheet, which I'll show you in a minute, with all of these on, and we get students to decode them. We've got the root of the word, which is words that have a meaning on their own. They often form the longest part of the word. Science has Greek or Latin roots. I love this one, chloros, isos, allo. And then the suffix appears at the end of the word. I think one of my favourite ones, actually, if you can have a favourite suffix, is ate when you're doing chemical equations. Something like copper sulfate, and putting them up on the board and doing the equations. And then when you've done the equations, just saying, what does that mean? Looking at it, the fact that it's got oxygen in, that sort of thing. That's one of my favourite ones. Not sure why. So here this is from one that I use all the time, and all of my students have this in their books. And if we come up against a familiar word, unfamiliar word, what I do is I'll say, can you break this down? Or one of our sort of do now activities would be, there's 5 words on the board here. I want you to have a go at breaking them down. And it works beautifully with A-level when you're teaching biological molecules, and you've got all your monos and dyes and saccharides. I just put a whole lot of keywords up, and then they work it out. And it's like, wow, I know what it means. And I've never heard of the words before. So that's one of my, as you can tell, my favourite things to do. And breaking down words. I think photosynthesis is probably one that we do really well. Now, I'm not saying spend lessons and lessons on this, but break down the words. And I, sort of look at it. I just put it on the board, use different colours, break it down, get them to use the root words sheets. And we have a bit of fun with some of these. So I look for the opportunities for this in every lesson. And I look for families of words, like in photosynthesis, translocation, transpiration. What does trans mean? It means to move, to transport. So linking all of those things together. And interestingly, on this one, a great little video where I stole this bit from is I taught photosynthesis, and I split it up for probably about 17 years of my career into just photo and synthesis. Photo means light and to make, and I didn't realise that it broke up into smaller parts. So etymology, it's knowing the origins of a word, and this is often the root words. Now, Alice Visifere does some fantastic work on this. She's a literacy and language, a literacy coordinator, whole school literacy coordinator over in Oxford. And if you follow her on Twitter, she has the most fantastic Dropbox with loads and loads and loads of resources on. So this is just an example of what she does. This here, you can find it on a Dropbox there. Linking to science here. So we've got therm, heat, how do we use it? What does it mean? It gives, so students, gives them options to do different things, and it's absolutely wonderful. She also, incidentally, has if you want to get students to do wider reading, a list of science books or science fiction books or sort of teenage reading linked to science, which is great. So knowing the words isn't just good enough. You need to conceptually link those words to build your schema. So even, I'm not a massive advocate for millions of worksheets if you can help it, but you can always jot a few words on the board. You can do this on whiteboards, on paper, it doesn't really matter. And then just do your conceptual links, and you can build a really clear map with this. So oxygen is a waste product of photosynthesis. Photosynthesis produces glucose from carbon dioxide and water, and you can make as many links as you can. And then after this, what I would generally do is I would generally then get them to write, say, a paragraph, because this is, you want them to be able to talk to each other. A really good strategy is that you get the students doing this and then say, right, now I want you to do a paragraph, do it roughly on a whiteboard or talk to each other, and then I want you to put your ideas down in, I don't know, 2-3 paragraphs, and you'd be surprised what they can do from these words. But I think it requires training and a little bit of support. So why is it important to model the use of scientific language? We need to explicitly model correct use of scientific language. You know, correct our students continually when they're talking about, I've got this cup here, I've got a spoon here, when they mean a beaker and a spatula. Avoid, you know, the news has been driving me mad with talking about the coronavirus, and people saying that the coronavirus is a bug or a germ. It's just not the language that we should be using. So rather than bug or germ, pathogens, microorganisms, talk about the language that is interchangeable. So that's one. You've got microorganism, you've got microbe, you've got pathogen. So you've got obviously a pathogen is a category of microorganisms, but it's that sort of thing that we need to be really, really careful of. Another one in chemistry, if we talk about things like chemicals, we use the word chemical, we use the word substance, we use the word material. And I think material is really important to stress what material actually means in everyday life. It's tier 2 or even tier 1. We know what material is. This is material, you know, that you saw with. But if we're just doing this quickly, students go, why was it material? I mean, I remember so I remember my son, when he was at school, it was about 8 or 9 in a lesson, and he was doing an ICT lesson. And his teacher said, Bill Gates owns Windows or developed Windows. And my son said, he must be really rich, Mum, because there's windows in every building. And he just missed the fact that it was Windows. So that's an example of what, you know, if we're talking materials, we need to repeat these words and reinforce these words. So this is from a paper by Carrier in 2011. So this is an example of what a student might say, something simple using everyday language to describe what's happening. The teacher might say, we mixed baking soda and calcium chloride with water, resulting in a gas, and heat was released. I'd probably say that I'd explain it as the scientist would, to be honest, even down to year 7. The combination of baking soda and calcium chloride is an exothermic reaction with the products of sodium chloride, calcium carbonate, and carbon dioxide. So it's about how we use that language. Don't simplify it, just explain it. So pronunciation. It's about having clarity of pronunciation. Obviously, I have an accent, and it can be quite difficult, especially when introducing new words. I've worked predominantly in schools in London, and my accent was even more pronounced when I first, not that there's an issue with that, when I first came to London. And I remember teaching a whole group of students chloroplast. as now they said chloroplast. So now I just make sure that we pronounce the words, and then we'd use their accent to their pronunciation and pronounce it clearly. And I say to a student in class, how do you say that? Chloroplast, chloroplast, miss, that sort of thing. But that's absolutely fine. It really doesn't matter. But just as long as it's clear pronunciation and students have actually got confidence to try new words. Here's an example of a word that my Year 12s came across when they were researching enzymes. And we were researching enzymes used in the home, used in industry, and I wanted them to find, just a quick research task, I wanted to find me 5 or 6 that were used in the home and industry and what they were used for. And then we were feeding back. And what I noticed was that every time they came to the name of the enzyme, they couldn't pronounce it, they couldn't say it, because they didn't have the confidence, because they've not come across this word. Obviously, this is very complex, but there's other terms that they won't have come across. So what I said was, don't worry about it. So that, and I said, well, can we try and pronounce it again? They were quite embarrassed. So it was something like, this enzyme is used in I don't know, the baby food industry. I can't remember what this one's used for, actually. The baby food industry, blah, 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 blah. And they go, and so I encourage them to do this. Write it down, split it up into its parts, and then perhaps even look at how it's phonetically spelled. Phosphor, fructose, kinase. So we looked at how we could do that. And now the students, when I say you come across an unfamiliar word, write it down, try and split it up, say it a few times, say it to another person, and then when you're feeding back, you'll be able to say it. And it gives them an awful lot of confidence. So here is one of my favourite quotes from Wellington and Osborne. Science educators are to also some extent language teachers, and that the learning of science is learning a whole new language. Just go into some MFL classrooms, ask your colleagues to go in when they're introducing new vocabulary, the word games, the way they do it, the sort of activities they do. Don't be afraid of doing spellings and some word games. Don't make it all about that. But if you know the language of science, you are 3/4 of the way to understanding the topic. So recommendation 3, developing a student's ability to read complex academic texts. Now, science is hard to read, whether we like it or not. It's challenging to read, and it will always be challenging to read. So we need to really make sure that we know this. Now, when I've done these presentations before, I ask people how children learn to read, and I'll ask a room of people, and there's invariably 1 or 2 people who put their hand up and they say they know. And it's not because we're teachers, because we're not trained on how students learn to read as teachers. We are trained, I've had no training whatsoever, but this is how children learn to read now. My children are much older, and they learn by whole words, but now it's by phonics. So a phoneme is the smallest unit of sound, and phonemes can be put together to make up words, and there's 44 sounds in the English alphabet. A grapheme is a way of writing a phoneme down, and decode is to read a word where you break it down, and encode is to spell a word. So those are phonics. I think it's Mind the Vocabulary Gap. I haven't got it with me, but by Alex Quigley explains all this beautifully. And I've only got Mind the Reading Gap because somebody's borrowed my Mind the Vocabulary Gap. So that's another recommendation there. So how do they learn to read fluently? They decode the word using phonics, then there's visual recall, reading the whole word on sight, and then there is recognition of the word with fluency, and it becomes automatic. It can take quite a while to become fluent, and if students aren't fluent, it's actually exhausting decoding these words. So when we give some text, when we give a student some text in a science book, it might be a real challenge for them to read that. And they're so busy trying to decode the words, if they've got poor literacy, that the meaning is lost by the time they get to the end of it. And I've heard this 95% before, and that students need to understand between 95 and 98% to be able to make meaning of it. And this is for second language learners. I couldn't find anything for first language learners, but if we're saying science is like learning a second language, like learning a modern foreign language, you need to know about 95 to 98% of that text, of those words, to be able to make meaning of it. It's exhausting to try and read. Just try and read an academic paper in something that's out of your field. It's impossible. Even in biology, I probably couldn't read an academic paper unless it was something that I knew pretty well. So the Flesch-Kincaid is a reading ease score. So I use this when I'm making resources, or if I want to know, because you can use it really easily on Word. So the higher the number, the easier it is to read. The lower the number, the more difficult it is to read. And bear in mind that many of our students don't have the same chronological, the same reading age as the chronological age. So this is a book that we use, and I just took an example of a page of this, and the reading ease was 71, which is age 13 to 14, 14 to 15. This is a year 7 book. So you might be asking the question, well, why is it so difficult to read? It's difficult to read because of the tier 3 vocabulary generally, because science is full of polysyllabic words, and the polysyllabic word will increase the reading age dramatically. Also the length of sentences. So to get around reading age, what's happened is that sentences become shorter, but if sentences become shorter and the text becomes simpler, sometimes you lose the meaning of that text. So science will always be hard to read. You know, it isn't that exam papers and examining exam boards are making it more difficult. It is difficult to read by the nature of it. There's some, I think there was a great, by the Science for You books, there was somebody did a paper on the Science for You books years and years ago. Can't remember his name, the guy who does that. And he did all about the difficulty of reading in science. I'll see if I can share that. And then, so this is a bit of a tricky one, because this is higher tier, but this is Hormones of the Menstrual Cycle. I teach this to year 10, and it's got a Flesch-Kincaid score of 60 to 50, 15 to 16. It's tricky to read. I mean, this is particularly one of the hardest topics anyway, I think, because there's so much involved in it. I quite enjoy teaching this, but it's quite complex. So not only is it complex, the language you use is complex. So as science teachers, we'll be able to read this really, really easily, okay, if we teach this, because we can manage that. But you give this to a year 10 student and you've not been through any of these words before, you'll find it difficult. And often we just say FSH. We don't say follicle stimulating hormone. I prefer to say follicle stimulating hormone, because it kind of tells you what it does. LH, luteinizing hormone, gives you no clue to its meaning at all. So it's quite tricky. But as science teachers, we'd probably be able to read this. So this is something that was done in the CPD at my school by our SEN team. And this outlined how it's difficult. So you might want to pause the video and take a little bit of time to read this now. So if you've taken the time to read that, what you'll see is it's actually quite a challenge. So in order to make that easier, there is, here we have the words and what they mean. Aglet, no idea what an aglet is. Under my little face here, there is, it's the bit at the end of the shoelace, the plasticky bit, but you can't see because under my face, it's just a diagram there. Defenestrate, to throw out of a window. Cacology, bad choice of words. I can't say this one. Alexithymia. There you go. I broke down my words. And then finally, we've got Dorifor at the bottom. And so all of these, what it actually means is that you can now understand it. But for many of our students, this is what we're presenting them with in science. We are presenting them with incomprehensible work. So how can we overcome this? There's several ways that we can actually overcome this. And this is sort of some of the things we're doing. So these are the strategies the science team at my school have used to improve literacy and language. We started with the why. So we looked at why is vocabulary important. We did a lot of training on vocabulary. So we went through these things with them. What's morphology and etymology? How do children learn to read? And how can we use oracy to improve literacy and language? So we talked a lot about how we need to speak, how we need to give students opportunity to use these words, not just see them as written text, to pronounce them, to become confident in the use of them. So we did our staff training. This is, my team have seen this. This is the training that I went through. We haven't finished it all, but this year we're just focusing on vocabulary. So we have, with our schemes, we have keywords with definitions every lesson. And what I particularly like about this is that you have the pronunciation here. So it gives confidence. So we used to have the keywords at the beginning of the topic and we'd say, oh, go back to the keywords. But now our third slide on every single one of our PowerPoints is the keywords. We give students a small sheet of the keywords. It gets stuck in their book. It's a bit of a pain, but the students are used to it now. It gets glued in the book, and when we use that word, they highlight it or tick it, but the teacher talks it through. We also get them to chant the words. It's lovely. You'll walk down the corridor and you'll hear, I don't know, endangered being shouted by the teacher or something like that, and then the students will chant it, just so they get used to using the words. And that simply means that when they get to an unfamiliar word, they know straight away in that lesson and they can go back to it. Not necessarily keen on some of the meanings. We probably need to simplify some of these as we move forward with this, but we're just using those at the moment. So these are the strategies that we use. We say the word, we write it on the board. If it's a keyword, we break it down, if we can, into its constituent parts. We repeat it, emphasising different parts of the word. We discuss the etymology. If the etymology exists, if it doesn't exist, we don't force it. We give a sentence using the word. We reinforce the vocabulary. We have spelling tests, and we do word games as well. And we've started now doing Google Forms for language, so we can do those for homework, which are great because they're self-marking. So that's what we do. Now, we also help them with the reading. What we do, we use a visualizer a lot. So I'll photocopy the text on a slide, I'll make it a bit bigger, I'll have the same, they'll have the books open. So we use textbooks, and I have them open we have them open on the page so that they've always got something in front of them. We teach students how to read them. So I will read the text while they're just listening to me, then I will use the visualizer and I'll talk through and I'll highlight the keywords, and then we'll go through the keywords with them, and then I will have them reading it on their own. So specialist vocabulary have been taught before. We read the text aloud. The features of the text are explained. This is adapted from national strategies from 2004, but we annotate the text together if we photocopy the sheet, and it depends what it is. Sometimes we'll have a nice comprehension where there's a nice big chunk of text and we'll highlight it, we'll do a bit of darts, circle the terms that mean this, underline the terms that mean that. But it's getting students to get used to reading the textbook. Don't just say go away and read the textbook. They can't do that, so we read aloud to them, especially in our for our lower prior attainers. So where do we find out more about literacy and language? I have books galore on this sort of thing. This is one of my favourites. It's old, but it's fabulous. And it's where a lot of the national strategy work was based on in the early 2000s. So that's my favourite one. And then we've got the national strategies, improving secondary science guidance report, and the education and chemistry. There are a plethora of articles on literacy. I've written a few. I know there's lots of others who've written. I think there was about 19, 20 articles just on literacy alone. So there's a lot on the education and chemistry. This here, review of socioeconomic status and science learning, from page 69 onwards, got some brilliant information. Fantastic resource from Emily Sieber, and closing the vocabulary gap, and also closing the reading gap. This is a superb book for anybody who wants to know more about how children learn to read. It looks at the challenges facing students with poor literacy skills. Anybody who's got a lower attaining set or students who've got poor literacy, I'd encourage you to read this. It gives some real insight and actual empathy. Bringing words to life. I've also written a little course which covers most of the presentation that I've put in today. So thank you very much, and I hope some of that's interesting. I'm AJTF71 on Twitter. Thank you very much.